కరెక్ట్గా తెలియదు ఒక వస్తువు చేస్తున్నాను చాలా బాగా అంటాను.
క్లాస్ రాసిన తర్వాత అయిపోయిన తర్వాత మనం క్లాస్ డిస్కస్ చేయాలి. లాస్ట్ 7th ఆఫీసర్స్ ఉన్నాయి కదా వీటికి, ఓకేనా? అదే మీ క్లాస్ నుంచి మీ 5 మెంబర్స్ కాకపోతే మిగతా వాళ్ళు, సో మీరు నేర్చుకుని ఇది చెప్పారు డిస్కస్ చేస్తే వాళ్ళకి ఒక ఇంట్రెస్ట్ ఉంటుంది. నెక్స్ట్ వాళ్ళు వస్తారు, ఇది రాదు, ఓకేనా?
the event will be started in a short period of time. Good morning to all. I, Srinidhi Reddy, student of AIML, welcome you all to the informative event, The Future Connected with IoT, Enhanced by Artificial Intelligence and Robotics. Here, we gather to delve into the fascinating world of Internet of Things and machine learning. This event is designed to provide students with comprehensive understanding of how these cutting-edge technologies are transforming various industries and everyday life. Now, I welcome Dr. A. Mallikarjun Reddy Sir onto the stage. Sir is an experienced academician with 15 years of experience specializing in artificial intelligence. Sir has completed his MTech from NIT Calicut and PhD in computer vision from JNTU Kakinada. To his contribution to the department, he has initiated 4 technical clubs and 4 professional chapters and organized many technical events under these. I request HOD Sir to speak few words.
I request Shreesh Chandra, please. Good morning to all. Very good morning to all. Good morning, sir. Yeah, good morning. And today we gathered here for an exciting event. You observe the title of the event also. The future is connected, IoT transformed by AI and robotics. In this, you observe the title also, it consists of 3 buzzwords. What are the 3 buzzwords? One is the IoT, second one is AI, third one is robotics. That I'll give that bit information about that, what do you mean by IoT and what do you mean by AI as well as robotics. First, IoT. What do you mean by IoT, anyone? Internet of Things. The Internet of Things, exactly, it means by the interconnected of networks. Why the interconnection of networks is nothing but a number of systems will be there, you are connected, you are calling it interconnected. This all the systems is connected over the internet. Why we are connecting this all the systems and all means to analyze the data. For example, IoT, for example, I think some of the today for the attendance, EC students also there, I think. EC students also there, EC. First, for example, you are placing some of the sensors. That sensors will collect the data. What is the data is collected by the IoT that you are giving to the artificial intelligence. Okay. What do you mean by artificial? What do you mean by AI? What do you mean by AI? Artificial intelligence, I know. What do you mean by exact definition of AI? The artificial intelligence is the one of the technology. It will mimic the human behavior. It will mimic the human behavior. You are training some of the systems. Based upon your training, it will behave like a human being. Once you are collecting the data from IoT, that data you are giving to the, it may be AI algorithm, it may be ML as well as deep learning. It will analyze the data, finally it will give the process. What is the job of robotics? What is the job of the robotics? By using IoT, you are collecting the data. After that, you are using AI for what? Processing. What is the job of robotics? That you can enjoy now, you are getting the 3D printing, n number of technology came into the picture. If you observe that robotics, by using the robotics, you are building n number of things, finally based upon instruction, it will perform a number of tasks. For example, what is the data the AI will processing? It will give the a number of insights, a number of meaningful information. After that, you are applying the robotics. Based upon that, it will do the a number of tasks. That is the main intention of the today topic. That's why the future is connected. IoT enhanced by AI as well as robotics. First, you are collecting the data. That is the job of IoT. The second one, you are processing the data. You are analyzing the data. That is job of AI. What is the meaningful information is generated by the AI? You are applying the robotics technology. That is the agenda point of the today event. And in the interacted yesterday class also, that is about importance of this one. And my appeal to all students, or my submission to all the students, be active in LIT. The LIT is nothing but LinkedIn, Instagram as well as Twitter. The professional networking also nowadays is very, very important. If you don't have any account, please create the LinkedIn accounts as well as Insta as well as Twitter. You attended any event, you get any certificate, you participate any hackathon, try to post what is the thing will be, what is the stuff will be there, try to post in the LinkedIn, Insta as well as Twitter. And one more thing also, if people are joining university, what is the difference, you can anyone, what is the difference between institute and university? Any difference between institute and university? Wide range of courses. For example, you observe that Anurag University, we are having the 6 different schools will be there. You want to develop any project like multidisciplinary approach and all. You want to give some solutions about medical field, you want to give some solutions about agriculture field, you want to give some solutions about nursing field also. Here the university students, you have a chance to work with multidisciplinary approach. Please try to understand. The last year also university we conducted Tejas 2K24. Now this, I think the proposal is also open that we circulated all in the class groups. Now we are also planning this time 2 days, not 1 day. That your seniors and you also, that last time the Department of AI we submitted 32 proposals for Tejas 2K24. My submission to all, please give some solutions to nursing, please give some solutions to, irrespective of any different schools also there in university, try to give some of the solutions by using the technology. Thus I call Shreesh also, Shreesh Chandra also. The Tejas 2K25, that is one of the platform to give a chance to, it is a platform, the students will develop a prototype, a product kind of thing, they will showcase that all the things. That each and last year also we conducted January 26th. This year also we are planning 34th, 25th, 26th. Okay, that is the request. And one more thing also, please, that multidisciplinary approach is required. And second one, please use the principle of lift also. LIFT lift. I think yesterday I interacted second years. I discussed all the lift. The lift is nothing but that company people also looking. You are good at networking. The technical skills also required. As well as that networking is also required. That's the usage of lift. The next one is lift. And L is nothing but leadership. I is nothing but innovation and intelligence. The T, F is nothing but flexibility. T is nothing but technology. The first, what do you mean by leadership? You observe that last Saturday, one of the moment your Indian, it is a proud moment is happened in last Saturday. What is that? World Cup. Be a leader like a Rohit Sharma. That you can inculcate how you can build up means you are having that n number of clubs will be there. You observe some of your seniors are the good leaders. The Monish is the president of the club. Agli the design team. Sanjana is also a good leader. Now anchoring, she did also excel. This type of leadership, that type of leadership qualities is required. The second one is innovation. Innovation that yesterday also I quoted in the classroom interaction. Dhoni, what is the innovation of the Dhoni? Helicopter shot. The previously that type of shot will not be there. That is the innovation of the Dhoni. Intelligence lead to innovation. Please apply proper intelligence, finally lead to innovation. The next one, flexibility. You observe what is the unique talent of Surya Kumar Yadav? 360-degree shot. That type of flexibility is required for whenever you are interacting with faculty, you are developing a code, you are proposing a solution. That type of flexibility is required. The last one is nothing but technology. The majority of the students you observe some of that, we also that very recently last week, the 704 lab, What is the systems? We created the good infrastructure. The RAM capacity is 24 GB, the terabyte will be there, i7 processor will be there. The creation of the infrastructure is very easy. What is the main task here? What is the main challenge? Utilization. Yes or no? Utilization is very, very important. Okay, now please follow the lift and please follow the lift principle also. That at last I would like to thank our speaker, Mr. Shreesh Chandra Srivastava. He is the IIITian and co-founder and CTO of ChargeCart. And that is the thing in this. What is the? You observe the catchy title is given by Shreesh Chandra only. That I observed last time also visited our campus. He is having good sufficient knowledge of these three fields. Interested area is IoT, AI as well as. The session will go for interactive. Please interact with today expert, and whenever you are having anything, you can directly ask the speaker. And the final year students, I appeal to all the students, and how to do the good projects by using IoT as well as AI as well as robotics also. At last, I would like to congratulations to Mr. Daniel Victor, the A2A Club coordinator, and entire team of A2I Club student coordinator, President Monish, Akhil, Sanjana, Bhavana. Okay. Thank you all. Happy learning. Thank you.
Thank you, sir, for us enlightening with your words. Now, with great pleasure, I extend a warm and hearty welcome to our distinguished guest of honor and speaker of the day, Mr. C. Shreesh, who started as an associate research engineer at ChargeCart and now working as a co-founder and strategic technology advisor at ChargeCart. Sir has completed his education in Bachelor of Technology in Electric Engineering and Computer Science and honors in Robotics from IIIT Hyderabad. He also did his Master of Science from IIIT Hyderabad. Now, I request Mr. A. Mallikarjun Reddy sir to felicitate the guest as a token of gratitude. I also request Victor Daniel sir and other faculty members to join the felicitation. Now, I kindly request HOD sir to take a seat in the audience and Sri sir to take over the session.
Good morning, everyone. How are you doing? How is everyone? A little bit of Josh? Just fine, not good, not great. Doesn't sound like great. Are you chilla ke bolo bhai? I'm feeling great. Say. Okay. So before we get started, we'll set up the system, right? Before that, I want to talk about something with you. So, sir gave a very motivating speech to you, and I cannot stress the point more that especially for getting industry ready, right? Your school, your college projects, do more projects in your college. The more practical experience that you can get, it's better. Getting course certificates is not that a big of a deal right now, right? People can do online courses and get many certificates. But if you can prove your skills by doing a project, right, that showcases startups, especially startups, because startups are looking for skilled people. Because most corporates, they will train you, but now the competition is much harder, right? You must be all aware of the job market right now.
So the more skills that you can gain, the better it is for you. So for cracking your placements and getting a good job, I would suggest do as much competitive programming that you can do lead code or code forces, and study data structures and algorithms. Apart from that, it is very important that you pick up one subject that you really like, and you go really deep into it, right? It can be IoT, robotics, or machine learning, or VLSI, any subject that you like, go deep into it, and do as many projects that you can on it. Okay, so once we get things set up, right, we'll start. So let's get started. So the title of the talk is Future is Connected. So Sir explained a little bit about this to you. So I've planned the session to be very interactive. So you can interrupt me anytime. If I'm going to continue on speaking, right, I'll let you know, and then you can jump in with your question once I take a pause. Okay, and I'll let you guys know. Okay, so okay, we'll start with the presentation. Okay, and I want you guys to be as interactive as possible, right? And I have planned this session to be an information overload. So it's going to be like drinking from a fire hose. So I'm going to bombard a lot of information. Okay, so the idea is that you get to know about good concepts. I'm also going to present some cutting edge research that is going on in the field. So you can get some ideas to build your own projects, right? You would know that now in the age of AI, right, it's more important to be creative, right? Just getting the skills is not important, because a computer will be able to replicate that. It is already able to replicate the basic coding and all that. So where you come in and where you matter, where the humanity aspect comes in, is how creative you are. Okay. So what is the internet? You guys know about all of this. Okay, so we'll skip on to it. Does anybody know what was the first IoT device in the world? Does anyone know about it? By the show of hands. Okay, how many of you don't know about it? Okay, so nobody knows about it. Any guesses? No, Arduino is very recent. Arduinos are actually created for artists. So that's why it's called a sketch. It's created in an easy way so that artists can implement, play around and build digital art. So yeah, that's a good fact. But Arduino is not the correct answer. Can you pass the mic around? Toaster. No, how is toaster an IoT thing? Explain. Why do you say toaster? Is there a reason for it? No, it's fine. Actually, giving answers is very good. Okay, you tried, right? That's very good. But okay, I'll now tell you what was the first IoT device. So the first IoT device in the world was a Coca-Cola machine. Yes, it was a Coca-Cola vending machine, and it was built in 1982. So it was modified so that it actually connected with the server. The internet existed at that time. It contacted the vending people, right, when they had run out of cola or the electricity was off, and when people had bought if the vending machine was empty, then someone would come in and load it back up. Right? So it was made in 1982 and it was Coca-Cola. So we'll talk a little bit about business as well. So do you know who made more money, Coca-Cola company or the people who were making the fridge? Any guesses? So how many of you say Coca-Cola made more money? Okay, 2 people. How many of you say that the refrigeration company made more money? Okay. The people who answered Coca-Cola are actually correct. So it was, even though they didn't create the refrigerator, they were the people who benefited the most from the refrigerator. That boosted up their sales. Earlier, Coca-Cola used to be served in ice box. If any of you are aware what an ice box is, it's a box you stuff ice in it, and the cola didn't you taste good, right? How many of you had Coca-Cola? I'm sure most of you have had, right? Okay. So when the Coke is warm, it tastes really bad, right? And if it's at a particular temperature, it tastes pretty good. How many of you have noticed that? You've noticed it, right? Yeah. If you nod your heads, that's also very good. Okay, it will give me some feedback. So the temperature was very important part for Coca-Cola. So out of that need came this machine, and it was made in CMU. So CMU is the #1 institute in the world for robotics and AI. So that is the place where all of this was happening at that time. So Mark Weiser in 1991, right, the guy on the left-hand side, he published a paper in ubiquitous computing. That was the first time the word IoT was used. And Kevin Ashton of Procter and Gamble, it's a very big company. So most of the stuff that you use, shampoo, all that, right? Behind all of that, it's P&G. So later MIT's he was associate Auto ID Center, and he also viewed RFID as the future of IoT and not the internet. So see how things have changed now, right? Because at that time they used to think that internet is very expensive, high bandwidth, right? Okay, this is so now I'm going to share a very intriguing video. So okay, tell me, just randomly people can speak up, right? When do you think the first smart homes came up? Smart homes, when did the flat screen TVs came up, right? When was voice activated home control, like Alexa and all that, you know, right? Google Home. So when do you think when all of this was first created? So okay, on this side, some. When the year, speak up the year when you think all of these technologies came out. 2000 something, okay. 2002, 2003, anyone more up? Okay, lower. No, lower.
1950s.
That guy is closer, but still a little bit higher. Slightly higher, you're close. Okay. So let's see the video. Why is the audio not good?
That's a television era. Well, this is a concept for TV of the future. This combines two different technology. Flat screen.
Try to listen very closely because the volume is a little low. Okay.
That's a television era. Well, this is a concept for TV of the future. This combines two different technology. Flat screen technology in terms of allowing us to make the unit very compact in its size, and also high definition TV in the sense of getting very well defined pictures. The idea is that this would be a flush unit that would fit against the wall and was very maneuverable, but you can always position
how
it
flat that TV is
when it's finished with, and it's linked directly into the raceway.
Now, Mark, with all these systems, how do we control them? Do we have a lot of these little infrared controllers like we currently do with our VCRs and so on?
Well, we think systems are going to become very much more important in terms of the way you control the whole environment within the home. Let me introduce you to Dennis Arsenault, who can talk to you a little bit more about systems within the house.
Hi, Dennis.
Nice to meet you, Steve. Dennis, can you demonstrate some of the systems within the house?
Sure. Voice command.
Good morning.
Who is she?
That's the voice of our computer. She's tied in through the house and she recognizes only the voices of the homeowners.
So only your voice.
That's correct.
Well, what else does she do?
Let me show you. Evening party. The evening party lighting mode is now set.
That's incredible.
So they said they're going to organize an evening party.
Through these loudspeakers. Amazing. What else?
Privacy mode.
That's amazing. She's closed these blinds here. Well, what else does she do?
Security report. Security report. The security system is now disarmed.
That's amazing. I hope she doesn't call the police on us, too.
Call the police.
The police have been called.
That's an amazing machine, but you can see real practical applications for somebody who's handicapped.
Absolutely.
Well, does she cook as well?
Not yet.
So I hope you were able to catch the accent, right? Okay. So can anyone? So I want to check how much of the information did you retain. So can you quickly name the technologies and the applications that they demonstrated? Speak louder, speak louder. Voice command, okay. Yeah, voice assistant, but what was it doing? What all stuff the voice command did? Yeah, security report, calling the police, right? Controlling the lights and the blind. Yeah. Anything else? Yeah, privacy, whatever. Controlling the lights and all that, right? That came. Anything else? Smart home? Yes, yeah, that is good. So, this was, okay, did you hear what did the guy said at the end? Towards more to the end. What's your name? Very good. So you were listening very closely. That is very important. Okay, listen even at the end. At the end. So do you think? Okay, when do you think this? When do you think like we will have cooking robots or cooking machine that will automatically cook for you? By which time do you think we'll have something like that? Which year? 2030. 2030. Someone said 2030. Someone else. 2030. Oh, someone said already have. Okay. Do you think we already have that? So this is from 2009-10. Now the technology has more advanced a lot actually from this one. Making coffee, right? Making coffee, making pasta. It automatically collects the materials, like the raw materials from the different shelves. Turns on the stove and everything. Okay. So actually, this is from 2009 and 10. Now this is a full-fledged product. Okay. 2 years back, the company is called Moley Robotics. MOLEY. So I hope all of it. So the expectation here is that you guys have your phones in your hand all the time. So unlike a classroom, I encourage you to have a phone in the hand, right? Always search, okay? Keep searching the stuff, okay? So Moley Robotics. And now this is actually a full-fledged product that you can buy. Don't worry, you will actually, I'll send the PPT. You don't need not take a picture. Okay, so some applications of IoT, I'm sure you know about like intelligent homes, smart cities. Okay, so I won't bore you with all of that. Intelligent hospitals. So this is a good buzzword that you should look out for. Okay, it's called AIoT. So if you search the internet with this term, so you'll find papers related to artificial intelligence that applies to IoT and how IoT applies to artificial intelligence. Okay, so remember this keyword. Also, there's a new keyword as well called RIoT, which is the application of robotics with IoT. Can someone maybe guess what could be a potential use case of robotics and IoT together? Okay, or aeronautics, you can include that. Anyone? Anything that you must have seen in the news or someplace? Speak of space. How? But that's, okay, you can say it's, it is RIoT, okay, good. But I'm looking for like many more devices at a large scale. You must have seen it around New Year.
Tesla?
No, not a Tesla. But good. Okay, how many of you seen drone shows? Yeah, so, good. So drone shows are an example of IoT applied to aeronautics, and drones are actually a part of robotics as well. So, and actually there's a huge startup gap here. So you cannot connect more than 500, 600 devices to drones. So right now people are looking for solutions that with which you can connect more drones together. And there are some unique challenges specifically with drone communication, so that they don't collide with each other, and that communication needs to happen in real time. Okay, so maybe you can search for something called UAV CAN, UAVCAN. It's a type of a communication protocol specifically for drones, but the hardware doesn't exist, right? So so you guys can get motivated and build that hardware to communicate with multiple drones simultaneously. Now they need basically a hotspot device which communicates to multiple drones, but that is very expensive and you cannot scale it up to a huge extent. So the current research atmosphere is that people are trying to make all these drones collaboratively work together, and they will communicate with each other. So let's say I'm communicating with you, right? She's communicating with him. Okay, everyone is communicating with each other, and they know their state and position in space at all times. Okay. So data and privacy is very important when you talk about IoT devices, because IoT devices are connected to the internet and they are all the time collecting data about you. That might be private information, right? If someone hacks into your device, right, it will be a bad thing. So in future, when you design IoT devices, you really need to take care of data security and data privacy. Both are two different things. Okay. So there was something called the Mirai. Okay, 1 second ago. There was something called the Mirai camera botnet attack. So how many of you know what is a DDoS attack? Distributed denial of service attack. So can you explain what is DDoS? Take up a mic. Can someone give him a mic? It would be great if you have some mic runners so that people can.
So the person who attacks will use multiple bots to connect to different networks without knowing them, and at last he will send continuous data flow to a server so that the server crashes.
Okay, very good, very excellent explanation. Okay, so basically what it does, it overloads the server. So your college might also be having Hikai Vision cameras, right? And these have a vulnerability. They're all coming from China, and basically the Chinese, I don't want to badmouth them, but they are actually putting a lot of security vulnerabilities in the hardware chip itself. Forget about the software, that's already there. Even in the hardware chip, they're doing that. So all of these cameras were actually hacked once. And what do you think might have happened? Like, what would have been the scale of the attack or the loss that this vulnerability would have caused? So you can see this. No, cursor is not visible, right? Okay. So that image, right? Basically, that showcases what is a DDoS attack in pictographically. So multiple servers or clients connecting to a single server, they basically overloaded. So imagine if multiple people start talking to you, right? They'll overload you with information, you won't understand anything. Okay. Believe it or not, this vulnerability took down Facebook. Okay, how many of you use Facebook now? Maybe not a lot. It took down Instagram, it took down Twitter, it took down GitHub. Okay, and they suffered a huge loss because of it. Okay, so that is the scale of like the damage that can be done by a small thing, right? The cameras don't have any sort of computational capability, right? They're very stupid in that aspect, right? They also cannot transmit a huge amount of bandwidth, right? The video feed that they transfer is very low quality, right? But by using many devices, and these cameras are everywhere, right? So they were able to take down Facebook, Twitter for 2 days. Okay, and also privacy also comes here. So in Texas, what people did, the Texas power companies actually they installed thermostats in people's homes to basically control the temperature, right? So what that did, why did they do that, was to predict energy demands when the energy demands were high, when people were using the air conditioner more, right? If everyone is using the air conditioner at the same time, the grid will collapse, right? So basically they dial down the temperature, right? So everyone would be using, would getting lesser cooling, but at the end, everyone benefits out of it, right? But in the middle of a very strong heat wave, what happened? They dialed it down a lot, right? So people started to suffer, right? So if you give your control of your IoT device to other companies, you don't keep it with yourself, right? So that can be used in a very negative way against you, right? So we keep doing yes to privacy, agree the terms and conditions, right? Whenever you sign up to something, right? And we don't know what we are signing up to. So something like this can happen, okay? So you know, right now a huge heat wave was happening, right? In Delhi, so many people died, right? Because of the heat wave. So you can think about, so just try to imagine the consequences of something like this. Okay, so I'll quickly go through some IoT protocols. Okay, so this is called BLE, Bluetooth Low Energy. It's a new Bluetooth standard which uses less energy. So if you've used Bluetooth, you would know it's very hard to connect, right? Especially on iPhones, right? They don't connect very easily, right? So this basically solves a lot of that, and it uses less energy, which means you can run this, use Bluetooth on battery, right? And you can connect multiple devices. It's very good for IoT devices. Okay, I jumped to the last segment. Sorry about that. Yeah, we are here. So, yeah, Bluetooth is very good for proximity sensing. Zigbee is a very low power communication protocol. It is used to communicate with radio devices. And it is low bandwidth and is good for short range communication. It is very reliable and secure, which unlike Bluetooth. Okay. Also, a fun fact, Zigbee actually operates on the Wi-Fi spectrum. So if you use Zigbee, right, in any of your projects, make sure you're not also using Wi-Fi simultaneously, because it will hamper the communication. Okay, this is a very interesting protocol and which has gathered a lot of attention in the past few years. It's called ANT. It is an ultra low power, very low power device. Okay, so think if I dig up this wall, okay, or this wall, and insert a sensor inside of it with a coin cell. Okay, you guys know a coin cell, right? It's used in computers for your real-time clock, right? So let's say I embed it in, I just put it inside the wall and I seal it up with cement, right? How long do you think that that sensor will last? For how long will it work? Rough guess in minutes, seconds, hours, whatever. Someone said 1 year. Okay. Anyone else from this side? Yeah, you cannot take it out. Once you put it on the coin cell, tell me how long do you think it will last on that single coin cell? Okay, it's 10 years on that single coin cell. So that's how good this sensor is. So you can embed it inside buildings and make your buildings smart, right? Throw it somewhere, and basically why is this so low power? It doesn't communicate to a single node. It intercommunicates with all the other nodes that are around it, and they pass on that information to the next nearest node. Okay, this is called daisy chaining. This is another protocol which is very relevant today. It's called OCPP, Open Charge Point Protocol. So it's being used for communication between different charging stations and the grid. Okay, so this is a special communication protocol that is used for that. Okay, how many of you think, let me give you a crazy idea. Okay, can I send internet data through power lines, like through this, let's say this is being powered by phase and neutral, right? So can I transmit data on the same one while I'm also turning on the light? Will it be possible? Not possible? How many people say that it is not possible? Why so few? Okay, how many of you think that it is possible? Okay, so I saw that hand come up first, so you need to provide a reason for it. Why do you think? Yeah, that girl in blue, I think.
I read it at a place on a Cisco website that it is possible because it has low frequency. This has different frequency and the power circuit has different frequency, the hertz. So the information will not collide at the same time and we can pass both the energies at the
Do you know how it is done? The mechanism behind it?
I actually read it, but now I don't.
Okay, you said they communicate on different frequencies, right? But see, the internet is powered on very low voltage, right? DC voltage, and AC voltage is running on this. Then how will you do it?
They don't interact with each other, they don't collide at the same time, so the information will be passed.
How would that happen?
They have different lines in the same path.
No. So I'm saying this same two wires that are you getting it, right? I'll connect something on this switch, right? And maybe you have another switch at that end, right? And I'll send internet. I'll connect a router here, and I'll connect my laptop with a LAN cable over there, and I want it to work on that same line, same power line that is giving 220 volts AC. I don't want to put any new power lines. Do you think that is possible? Everything might not be possible, right? So, do you think it is possible? Now, do you think it is possible?
Not to the fullest extent maybe, but to some extent it is.
How? You need to then provide, right? Why do you think it is possible? So don't think of this as an interrogation. So basically I'm trying to develop your thinking skills, okay? So why do you think? It's a good thing that you answered, but why do you think? Think about it. Why do you think that it should work? Is there an intuition behind it?
Not much idea.
Okay. Anyone else? Okay, how many people think it is possible now? No one thinks it's possible now. Okay, how many people think it's impossible? So you don't think, you're not thinking anything? Come on, you should shut up. Am I boring you? Come on, anyone? You guys are shy. Come on, anyone? How about you? Do you think do you think it is possible? Maybe. What do you think? Okay. Good. That's a good answer. Okay. See, I don't know is also a perfectly good answer. Okay. So how many of you say I don't know? Okay. I don't see many hands, so the other people will need. I'll pick everyone out and I'll make you answer. Why do you think it is possible and not possible? So how many of you think I don't? How many of you say I don't know? So you're not confident. See that I really like that about you. You're confident in that you don't know. That's a very good quality, right? That's the mark of a very good researcher. So other people are not that confident in knowing or not knowing. Okay. So why I'm saying this? Not knowing that you know is also very important. Okay. It drives you. It basically lets you know what you should know. Okay, what are the questions that you should ask? Okay, so it is possible. Okay, when I'm talking about it, it is possible. Okay, so it's called HDPLC, right? Power line communication, PLC, not the PLC which is called programmable logic controller, not that. This is different. Power line communication, and you can communicate. You can send data, right? Connect a router over here, right? And transmit internet data and receive it at the other end. Okay, how does it work? It works by changing the basically you know about inductive oscillations, right? Inductive and capacitive oscillations, right? So basically it modulates the power line on the neutral line right? It changes the inductance. So it basically sends a pulse across in AC only, right? Alternating current, and you can actually get data, right? So do you think right now, do you think where it might be getting used? So it's, okay. Smart, yes. But right now, people are not using this in smart home. So this is a very good gap to come in and develop devices on this. Because this company called HomePlug, right, developed this protocol, and it was proprietary, which means it was paid and closed. So now the company went bankrupt and nobody knows, there is no other standard, right? So you can build a device on this. Okay, some proof of concept as well. Okay. Actually, I know a friend of mine from TR who's actually built something like this in India. Okay. It's also used, believe it or not, for communication between the charging station and the car, the electric cars as well. So they communicate on that power line itself, the DC or the AC, whatever it is being communicated. They use this same communication protocol. Not on the power line, they are separate lines, but the communication protocol is the same. Okay, yeah, I already came to this slide, so no. So do you think, can I connect, basically I already showed you the slide, right? So it's also possible to connect two Wi-Fi devices together. So I can have one phone and another phone, right, and communicate through Wi-Fi between them. You need not actually connect to the internet. People think IoT is also about connecting to the internet, which is the World Wide Web, right? You need not connect to the internet and waste bandwidth and data. You can communicate directly to your sensors through Wi-Fi, right? And do whatever with the data that you want. You need not connect to the internet called the World Wide Web. The Internet of Things is an internet of itself, a different kind of internet, right? So you don't need to connect, even when you want to connect on Wi-Fi, to the World Wide Web. Okay, so this would be very useful if you want to create some projects. Okay, there is also something called cognitive radios. Basically, multiple stations, mobile towers communicate with each other intelligently. So I've linked some papers in this, or you can look it up if you're interested in that area. Okay, so I think, how much time do we have? 1 hour we have, okay. Okay, I'll try to go through this a little bit faster. Okay, so this is, we'll talk a little bit about computer vision. Okay, so this is a good technology. I'll play the video.
In this example, the pulse signal is amplified 100 times.
So I'll explain what is this about. So what they are doing is they are calculating the pulse of a person, the heartbeat of a person through cameras. They're amplifying the change in skin color, and basically whenever blood is pumped, right, your face gets very slightly red, right? So they are using computer vision techniques called motion amplification to increase that change, whatever is happening in that pixel, and from that they're actually calculating the heartbeat of a person, and they have showed a very good use case for this, which you'll get to know.
In this example, the pulse signal is amplified 100 times. We can also analyze the frequencies of this signal and extract the heart rate. This doesn't require attaching any sensors to the patient, and the accuracy is comparable to hospital-grade monitors. The same algorithm can also reveal imperceptible motions, like the pulsing motions of arteries in the wrist.
You can see how the veins are moving. Right? You can visualize it with this technique.
When a person fixates at a point, the eye may move from subtle head motions or from involuntary eye movements known as microsaccades. Such motions are very hard to notice, even in this close-up shot of the eye, but become apparent when amplified 150 times. Invisible motions are also created by mechanical parts, such as the shutter and flipping mirror in a DSLR camera that produce tiny motions when taking pictures. Structures are designed to sway in the wind, but their motion too is often invisible. Amplifying the changes in this video reveals the swaying of the crane's mast and the undulation of its hook.
We'll stop there. So quickly, what all applications did you notice over there, and how do you think you can apply them and make use of them? Yeah, I wanted to be interactive. So what did you see? Any application that you noticed in the video? Yes. Where are the mic around?
We can use the wheels, the movement of wheels we can use in controlling things, whatever, by creating some motions.
Good thing. You can also use that for diagnostic purposes. So I think you have a new medical college coming up, right? And Mallikarjun sir was talking about you need to think about interdisciplinary applications of things. So for for care of babies, right, you can't attach sensors to them, right, which are used for adults. So this can be used, you can create a low-cost system, right, for monitoring babies. So many of the government hospitals, right, they cannot afford those expensive diagnostic tools, right. So just with a basic Raspberry Pi, the library is open source, right? You can build a small device and provide it to the hospitals, right? You might have also noticed that they were showing that the eye also twitches. When you're actually looking, you don't have any emotions as well, right? So your eye actually twitches very slightly to update the vision information, to update what you're seeing, right? So that you can get a clearer picture. So if there are some defects in someone's eyes, right, you can use this. Ophthalmologists or eye doctors can use this to detect some anomaly in someone. Okay, so think creatively. Any other applications that you might have noticed? Is it getting boring? Do you? Okay. So one was actually noticing how do cranes and how they're behaving. So if a crane is about to fall or break, right, you can notice about it preemptively. I think we can skip this. This is the same. Okay. Do you think you can recover sound? So this video is very interesting. Okay. It shows how you can extract sound from video and video alone, right? So it can be used for spy purposes. So let's say some discussion is happening in UN, right? You might have noticed the international dignitaries, they go to the side, right? Then they talk about something, right? So but the mics are not there, but the camera is on them, right? So this can be used to get to know what they're planning and what they are talking about, right? Which is very dangerous.
When sound hits an object, it causes that object to vibrate. The motion of this vibration creates a subtle visual signal that's usually invisible to the naked eye. In our work, we show how using only a video of the object and a suitable processing algorithm, we can extract these minute vibrations and partially recover the sounds that produced them, letting us turn everyday visible objects into visual microphones. In the silent high-speed video shown here on the left, we see the leaves of a potted plant shown on the right. The video was recorded while a nearby loudspeaker played the notes to "Mary Had a Little Lamb."
That is actually recovered from the vibration of a leaf, right? And there was no mic over there, right? So this is actually very interesting application that they applied this a similar technique to. So they took up pottery, right? Or you must have read in the news, right? That people find old earthenware right, buried somewhere from thousands and thousands of years ago. So they basically looked at the how that okay, how should I say this? The grooves on the pottery wheel. So you know how a pottery wheel works, right? So so many people used to use a brush to make it smooth, right? So they looked at how the grooves were there on that pottery, and they recovered sound information from that. So they were able to find out what people were talking near a bonfire 2000 years ago. So you can do many interesting things, right? This is, we can skip this, okay? So these are some papers on video magnification. So if you click the click the QR code, you can follow this. I think we can skip this. So basically, this is about using getting sound getting image or 3D models from ultrasonic sensors. So use many ultrasonic sensors arranged in a grid, and from that you can actually create 3D models without using a camera. And this is actually very old research. Okay, so this is the papers on ultrasonics. This one is actually pretty good. Do you know you can actually turn your Wi-Fi router into a camera? Yeah. You can do that. So this is a 3D mesh recovered from a Wi-Fi router. They converted a Wi-Fi router into a camera which can see behind walls. So let's look at the video. So this is from, again, CCL MIT.
This video describes a device that can capture the human figure through walls using RF signals. We place our device behind the wall, and it can see the silhouette of a person who walks in an adjacent room. The device works correctly, even if the room is completely closed. For example, if a person stands behind the wall, the device's output looks like this. In particular, the output on the right shows the background in navy blue and the various human body parts in red, orange, and yellow. Here, we can see the person's head, chest, arms, and feet. How does this work? The device operates by transmitting wireless signals that traverse the wall, reflect off the human body, and come back. At every point in time, only a subset of human body parts reflect the signal back to the device. Here, we show the output of the device as the person walks. At different points in time, different parts of the human body reflect the signal, and the device captures multiple snapshots at various points in time. It then combines these snapshots through a reconstruction algorithm that allows the device to recover the human silhouette through the wall. Here, we can see the person's head, chest, arms, and feet. The device can distinguish between different people behind the wall. So for example, over here, we ask two different people to stand behind the wall, and this is the output of our device. By training on different subjects, we can use a classifier to distinguish between them. The device can also distinguish between certain human postures. If the person stands straight, the output looks like this. While when someone stands in other postures, the device's output reflects his postures. The device can also track human limbs from behind the wall. Here, we show a scenario where a person draws a shape in the air, and we show the output of our device to the right. The device can trace the person's hand with high accuracy. We compare the device's output to that of a Kinect placed directly in front of the person and show the Kinect's output in red. In comparison to Kinect, our median error is around 2 centimeters. For more information on how the device works, check out our project webpage.
So as you notice, right, you can see behind walls, and you can convert any regular Wi-Fi router to this kind of a device. The code is also open source for this, right? So you can convert any router that you have into a camera that can see behind walls. And I mind you, this is very complicated research, but you must have seen, right? Okay, how many of you understood what they did? 90, 60%, 70%, any, you were able to grasp, right? How, by a show of hands, how many of you got at least 40%? Okay. So that shows you that it's very complicated research. So that also shows you that communication skills are also very important. How do you showcase your work, right? How do you tell, how do you describe it is also very important. That's why creating good reports, right? Creating good lab files is very important. That gives you the necessary skills in the future to describe your work, even if you don't go into research, right? In work, this will also be very important. If you get a good idea, a new idea in your company where you're working, right, and you want to present it to someone, if the other people are not able to understand you, then your idea is worthless, right? Even if it has a lot of potential, so your potential would get wasted. So it is very important to learn communication skills, and college is the best time to do that. Okay. And do as many projects, hackathons you can do. That will basically develop your communication skills. Yeah, this is just a same thing. Okay. This is the paper on Wi-Fi vision. Okay. Now this is very interesting.
Can you put the previous slide? Some of them want to take a photo.
Okay. Anyway, I am going to share this, okay? So you will get it later. Done? So, this is very interesting. Now, this is very cutting edge research, like a few months back, okay? So, right now, how many of you watched the NVIDIA show? The presentation that Jason Yang did. How many of you watched it? Okay, you should keep up with the industry, okay? What is happening in the field, because that, even if you are not in the AI or something, right, that is going to affect us societally as well. So, if you might have noticed, he talked a lot about humanoid robots, right? And why is that? So, this is an application of LLM onto robotics. So basically, you provide a prompt, bring me a green ball or something, and the robot hasn't been programmed what is a green ball, it doesn't know what is a green ball, okay, it doesn't know where it is located, right? It has not been explicitly trained how to do this task, okay, it doesn't even know specifically told what is picking. So the guy tells him to bring chips for him, and the robot knows that the chips is in the drawer. It opens the drawer and brings it. It hasn't been told explicitly that the chips is inside there. It saw it previously, someone putting it in there. So it's ChatGPT for robotics. And the good news is that this library called RT2 from Google is free and open source. So you can build a project on this, maybe build a low-cost robotic arm, and then you can play around with this. Now the library is very difficult to set up and get a project going, but don't let that discourage you, right? This is very cutting-edge work, right? And this, so if you work on this, right, and if you show it in your CV, the guys who will show it to don't even know what is a robotic transformer, and they'll be very impressed of you, okay? So this is just a small video, so it gives an overview. If you
imagine controlling a robot just like you interact with ChatGPT. DeepMind just released RT2, a model that can respond to natural language commands with low-level instructions that a robot can understand. RT2 leverages vision language models trained with billions of images and text descriptions from the internet to perform visual reasoning tasks, like captioning images or visual Q&A. These models are then fine-tuned with robotics data to respond to task descriptions and images from the robot's camera with the actions that lead the robot to accomplish that task. But here's the kicker. The models retain the knowledge that they learn from the internet images, recognizing objects, people, context, even if they haven't been explicitly trained for it. AI models are becoming better at imagine controlling.
In this, right, the robot is actually pushing a block instead of picking it, right? So this is also very new work, which pushing an object is also not very easy because the robot doesn't know what is the friction between the table and the thing, right? And to accurately make the block move in a particular path to a particular goal is extremely difficult because you might know friction is a non-conservative force, which means basically it is very difficult to model. So this is very difficult to do, and this model is doing it very easily.
A robot?
Actually, a colleague of mine, he came last time, Priyansh, if someone of you might have been there. Right? So he's working on this.
Just like you interact with ChatGPT, DeepMind just released RT2, a model that can respond to natural language commands with low-level instructions that a robot can understand. RT2 leverages vision language models trained with billions of images and text descriptions from the internet to perform visual reasoning tasks, like captioning images or visual Q&A. These models are then fine-tuned with robotics data to respond to task descriptions and images from the robot's camera with the actions that lead the robot to accomplish that task. But here's the kicker. The models retain the knowledge that they learn from the internet images, recognizing objects, people, context, even if they haven't been explicitly trained for it. AI models are becoming better at transferring skills across domains, and that trend is only accelerating.
So how many of you found this very cool? Okay. So are you enjoying it? Yeah. You look bored, sorry. Okay, I'm sorry about that if I'm boring you. Okay, we'll move on to a live demo, right? I think you guys will really like that. Okay. So we can skip this part. This is an application that a company is working on, and it's live there in the market. Okay, outside in US. So this is an application of IoT and machine learning. So it's for creating smart parking sessions. So we can skip through this part.
Half the world's population lives in cities, rising to 60% by 2030. Urbanization creates unique challenges, including traffic systems overburdened with increasing numbers of residents and commuters. Congestion is a major issue. Drivers spend an average of 20 minutes or more looking for a parking space. Parking is clearly in high demand, making it an increasingly important asset for cities. Meanwhile, parking surge traffic increases emissions and makes for unhappy drivers. Parking should be smarter. Enter Clever City. Imagine a future where arriving in a city is a seamless experience. Each driver is guided effortlessly to the nearest available space. Clever City's overhead sensors accurately provide real-time data on available parking. Digital signs combine all parking data and navigate drivers at every turn to the nearest space quickly and efficiently, reducing surge traffic and emissions while enhancing the driving experience.
So think about it, this can be a very useful thing for multi-level parking, right? Let's say, I don't know about here in Hyderabad where it's very difficult to find parking, but in Delhi, in Chandni Chowk, it's extremely difficult to find parking, and if you don't park at the right place, some random place, your car is more likely to get stolen than actually get confiscated by the police. So this is very good for finding good parking spots that is nearest to the place that you want to go, right? Let's say you want to go to this particular market, right? So you can, this system would be very good for doing that, and you can implement this using CCTV cameras. You need not use laser, radar or some other fancy technology. So, how many of you have gone to a multi-level parking? Okay, so you must have noticed, right? They have some sensors, like a green light is on the top, right? So basically they embed a very huge coil inside the ground, right? Which is very big civil work, right? It's very expensive as well. The sensors are also very expensive. So if you integrate all of this system with cameras, right? It makes it very easy. And I'm going to actually give you a demo, right? Using which you can get started on this in 5 minutes, right? Getting object detection and all that, right? Okay. So another really cool thing which I really like is which will be coming up, right? Which are called AI advertisement boards. So basically, you will have cameras mounted on top of billboards and these advertisement panels, and they will look at you. Okay, they look at your clothing, whether you're a girl or a boy, are you a man or a woman, are you a kid, what is your age, like which kind of clothes are you wearing, what is the color, and depending upon that, it will create a profile of you, and it will show you, let's say you're old age, right? It will show you an advertisement of health insurance or maybe medicines, or health, or if let's say you're a little obese, right? And it will show you advertisement of a gym membership, right? If you're a kid, right? Maybe it will show you an advertisement of families, right? Basically, what this is bringing online digital marketing in the real world. So think about how revolutionary it would be in the advertisement space. Okay, how many of you know that how do newspapers and news channels make money? Can anyone tell me that? Yeah, advertisements, right? So they fund their entire operations through advertisements, advertisements alone. So you can see how much money there is in advertisements. Even Facebook, Google, all the giants in the world, right? They all work on advertisements. Okay, when do you think this will come up? Right? Which year do you think this will come up?
Within 5 years.
It is? It is existing. Where did you see it? You didn't see it. Okay. Does anyone know, or did anyone see some technology like that somewhere, read something? Where did you read it? See, the reason why I ask these questions is because so that you get thinking, right? Also, you're able to then anticipate when some certain technology is going to come into the future. So that will make you a very good engineer. You'll be able to identify what is the timeline that something like this is going to come up. You can build a product around that technology and make good money out of it. Right? So when do you think this thing will come up? Or does it already exist? Where did you see it? Lenska does that? But it's online, right? No, but I'm talking about this being in the real world. An actual board or something in the real world with a camera on top of it. Did you see it anywhere?
In Shark Tank we have seen.
Where?
In Shark Tank.
Shark Tank?
One company was there, it had a mirror-like structure. There,
oh, I remember that. Nice. Good. Yeah, I had forgotten about that. Very good. Yeah, I learned something new. Cool. Nice. Yeah, they also do the same thing. But see, a mirror is not, it's like more of a personal item, right?
Yeah.
It's not in public. Anything in public? No. How many of you have gone to the airport? To the Hyderabad airport? Did you see those trolleys? The blue ones, which has a smart screen on top of it? Okay, did you notice it carefully what it is? As an engineer, you should be always observing the technology around you and what it is made up of. So many people picked up their hands. Can anyone tell me like what it does? Basically, what is their business model? What does that system have? I'm sure like all the girls here picked up their hands, right? We can pick up someone randomly. Not many people are participating. Okay, okay, how many people went to the airport? Lesser hands now, okay. So you seen that, right? Have you seen it, right? Okay, what did you notice about it? First of all, very good, you're very courageous. Okay,
I've seen a machine which gives us water, like no sensor. If you just stand in front of it, you'll ask several questions, either if you want a glass or a bottle, or you just want to place your mouth. We can choose whatever we want.
that is a vending machine.
Similar enough to it.
Okay, no, I'm talking about trolleys. Has anyone seen the smart trolleys at Hyderabad airport? No one?
No.
Okay, now there's a company, they have smart trolleys. When you go to the Hyderabad airport, right? Look at those trolleys. Basically, they have a camera installed on top of it, right? They keep looking at your face all the damn time, right? And what they're seeing, what they're actually capturing the information is, but so they know your location at all times, right? And they do it with Wi-Fi and various technologies to locate you where you are, and they're looking in which direction you're looking at, right? So there are multiple stores, right? So if you pass by a particular store, right, they'll show you that advertisement. That is their idea. So it is an application of that. But this has already been implemented some time ago, and there's a IBM AI bot called Watson, which actually did something similar, and the companies that used it, right, were able to get a 71% reduced cost per click by these advertisements, because the advertisements are targeted, right? Advertisements are sold, so they have to spend lesser money and they get higher sales. And McDonald's also did this. McDonald's created a billboard, and whenever a kid passed by that board, they showed the kid a picture of a Happy Meal. That is pretty cool. And that really boosted their sales for Happy Meals. And you know, right, the Happy Meals cost a lot, right? And that's just plastic. So McDonald's makes a lot of money, the highest margin on Happy Meals. Okay, now we'll move on to the live demo. Can we get a time check? How much time do we have left? Half an hour? I'll try to do this a little fast. Okay. So what is Firebase? Okay, we'll not do a demo on this because it's sufficiently easy, right? So you can follow this online. So Firebase is a real-time database. So you might have been using static databases like SQL, right? How many of you have? I'm sure everyone has used SQL, SQL, MySQL, or PostgreSQL, right? But they are very slow. First of all, the query times are very slow, right? And you have to create multiple tables, right? If you know, it's very tedious to build. But in Firebase, you don't have to do that because it is a NoSQL database. It stores the information in JSON format. So this is very suitable. This is actually the best solution for IoT applications. So if you're building an IoT application, right, or an AI application, because of the kind of data that you're collecting, right, SQL tables are not suited for it. You need to store it in a different format, right, which can only be in a different structure, which can only be done with JSON, right? So this database is very good for it. Also, it updates the information in real time. So if you're getting information from multiple sensors, right, it will update it instantly. And guess what? This is free. You can store 10 GBs of data for free, and it also provides authentication for users up to 50,000 monthly active users. So if you want to create a startup idea, you can get started on this, right? So yeah, I already explained that Firebase is NoSQL database. Okay, so now we'll move on to the demo. Okay, so I'm going to give you a small demo. The idea is to introduce you to the technology, and basically you'll get to know what this does and doesn't do, right? So that you can get your hands dirty later on and implement some applications on it. Okay, so I'm going to talk about Google ML Kit. Okay, it's a on-device machine learning framework. So basically, by using this, right now you might, you will have to run machine learning algorithms on the cloud, and even if you run it on a local PC, it takes a lot of time, right? It is very computational intensive. But this will run on your mobile phone without the internet. Run natively on your mobile phone because it's a lightweight ML model. And this is very good for deploying on mobile and edge hardware, so very good for IoT applications. Okay. And because it's lightweight and all that, right, it's really good for solving real world problems. Because if we want to solve the real world problems, we cannot buy expensive servers, everyone can't get that kind of a computational power. You also need a lot of energy to do that, lot of money to do that, and our society cannot afford that kind of a thing, right? So this is very good. Even rickshawalas today have mobile phones, right? So if you come up with a good application, you'll be able to touch everyone's lives. Okay? So it has very good templates to get you started, right? Very basic examples you can code and implement your own code on top of it. And it has many NLP and vision-based applications. Okay. And it works offline, like I told you, and it's free, all of it. Okay. So this is the link for this. If you can open this up, I'll set up the demo in the meantime. Okay. If you opened it, like you must have landed on this page. Okay, so you can see that there are vision applications. So I'll explain what all this is, right? You can even do digital ink recognition. So I can actually show you a live demo right now. You can write something, right, and it will detect what you have written. You can also integrate translation, all offline. It's all offline. Intelligent replies, translation. So you can go through all of this in your free time. Today I'll actually I'll show you a showcase on this. Okay, the Vision Quick Start. If you click on this, right, it will open up this library. Okay, what you need to do is open your GitHub. You can use GitHub Desktop. Okay, copy this link. Okay. Open GitHub, go to add, clone repository, paste this link from URL, paste the link. I didn't copy the link. So you can paste the link and then clone this on your system. Okay, so this will download all the codes to your system. And then I've already cloned it. Okay. So if you go look at the file system, so you can implement, this is available on both Android and iOS. So I have an Android phone, so we'll use Android. Okay, Android, and then we'll go to Vision Quick Start. Okay, so this is where the app is located. This is the application. Okay, I'll just start this app. I've already compiled and played the app, so I'll actually connect my phone device and then I'll show you. So you can click new project. Basically, you need to download Android Studio, then click on new project. I have already made the project, so I'll open this. Once you open new project, you can click this. Okay, you can go to File, Open, and once you click Open, you need to go to that particular file, right, where you have cloned, wherever you have cloned this, and click on that part and do OK. Okay. I've already done that, so, and this is the app. Okay, you need to click on Run, and this will compile the application. So, you can. How many of you have made mobile applications, mobile apps? Android, iOS, and Flutter. You do it? So this is very good. So don't update anything. Okay, maybe the dependencies would break. Just let me set up my phone so I'll be able to stream what's happening. By the way, how many of you go to the gym? Is there anyone who can do 10 push-ups and 10 sit-ups? That guy. Okay, I would need you. Okay. Anyone else as well? Okay. Okay, I'll call you up. Oh, by the way, don't worry, I'm not going to give a punishment. So this is the device. Now it's connected with the USB.